In this video, I'm going to go through a programming problem using C#, but instead of using the standard procedural or imperative style that you often see in C#, we're going to use a functional style. We're going to use the FizzBuzz problem to illustrate this programming style. If you're not familiar with FizzBuzz, it's a relatively straightforward and simple program or problem where you print out numbers 1 to 100, and when the number is divisible by 3, you print out fizz. When it's divisible by 5, you print out buzz, and when it's divisible by 3 and 5, you print out FizzBuzz. If it's not divisible by any of those, you just print out the number. So for example, an example of the output would be 1, 2, fizz, 4, buzz, fizz, 7, 8, FizzBuzz. And when you got to 15, you would say FizzBuzz because it's divisible by both 3 and 15. The idea of this is it's a very straightforward problem and great for interviews. If you are interviewing, you should definitely know this. So before we actually start writing this, if you have not written this program before, go ahead and do it yourself. Pause the video and come back, and you can see what the different style looks like. So let's get this kicked off. So let's outline and sketch out what we want to do in our program before we start writing it. So the first thing that we'll need to do is generate a list of ints from 1 to 100. And actually, let's, instead of going to 100, let's actually just keep it to 20, just so we can print it clearly on the screen. Once we have a list of items from 1 to 20, then we're going to want to do a transformation. In functional programming, much of the time, what we're going to be doing is creating a data pipeline and transforming the data that comes through it. So in this case, our data pipeline starts with that generated list of integers, and we'll do some type of transformation. In this case, we're going to go from int to string. And while we do that, we'll also apply some logic to that data set, to basically each value that's coming through that stream of data or data flow. And then finally, as all good programs, we need to output some data. And in this case, we're just going to write strings to the console. Okay. So let's get this kicked off. So we first want to start with a list of strings. Oftentimes, we'll think of going through in an imperative style or in a procedural style, we'll go through a loop incrementing each time we go through that loop. In functional style, what we'll do is we'll start with our input, or kind of our, in this case, a list of strings. So we want to generate a list of strings, generate a list of integers. And to do that, we're going to use the range function. And the range function is essentially going to take two items, or two integers, so int, so I and j, and output a list from I, or we'll just do to j. Okay. Now in functional programming, because this is a relatively common thing that we want to do, what we're going to do, or there's actually a built-in functions that do this. So, or operators that do this. And what you'll see in some languages is the dot dot operator. So in this case, if we want to go from 1 to 20, or generate a list from 1 to 20, we can use this dot operator. And this would generate a list from 1 to 20. Up at the top, I've imported a library, and this is the system.link library. Link is a library that was put in, I believe, in .NET 2. It's been there a very long time, and it is solely based on functional programming concepts, and it is based on functional programming concepts, and so we're going to use that. You may be familiar with the IEnumerable interface. There's a concrete class called enumerable, and it has a range function on it. So let's just go from 1 to 20 in this case. Okay. So once we execute this function, it will return us. It's a lazy list, but we can think of it as a list of items from 1 to 20, or list of integers from 1 to 20. Next thing we're going to do is we're going to use a function called select. In other languages, you may be familiar with it, and it is the map function. But select actually takes a function, and in this case, it takes a function that has an integer input and returns a string. And in this case, we'll just take that for the time being as an example. We'll take that integer and turn it into a string. So if you're not familiar with this syntax, this is what's called a lambda. A lambda is a function that does not have a name associated with it. You'll also hear the term delegate used. But essentially what this is a function that in this case takes one argument. You could also have j and k and other arguments. So these are the parameters to the function. We'll just supply one function, and then this is the body of the function. In this case, and generally we'll try our best to supply what are called expressions as the body, as opposed to sets of statements. That's just a functional paradigm, or functional programming kind of paradigm, idea or concept that we'd like to strive for. Anyways, so what we'll be doing is we'll be transforming each value in the list with this function, and the function is going to go from integer to a string. And lastly, what we'll do, and we'll get into more talk about this in a moment, we're going to have to actually cause this list to be processed. We'll come back to this. And then we'll want to iterate through each item in the list with the for each. And again, here we'll pass in a function. And in this case, it's going to take a string, and it's going to return nothing. So what that means is it's going to do something and put things out into the world, but not actually return anything out of it. So in this case, console.write, and we'll just pass in our string. And so this is our basic program. Now, it doesn't do anything other than transform from int to string. We'll come back to that. Let's just make sure that we're compiling and we can run this correctly. So .NET run, and we get 1 through 20 as we expected. So let's go ahead and add some actual logic to this. So to keep things familiar and a little bit more comfortable than they would be otherwise, let's go and actually use if statements to build in our conditional logic. And hopefully you will have, this should be familiar to you. So I'll just go through this quickly. So I modulo 3 equals 0. And in this case, we will return a fizz. And we'll just copy this a couple times. In the return case, we'll do i.toString. And so we'll have the 3 case, we'll do a 5 case, and this will need to be buzz. And in the 3 and 5, we'll do the buzz to make that first case that. Okay, so that will reformat. So if it's 3 and 5, return FizzBuzz. It's 3 fizz, 5 buzz, and 2 string. Let's go ahead and run that again. All right, so 3 is fizz, 5 is buzz, 6 is fizz, and 15 is FizzBuzz. All right, so we have our basic parameters that appear to be working. And now, if we look at this, should be, it's relatively straightforward to an imperative programmer. But if statements in C# contain statements, they are statements. That's why I said if statements. But what we strive for in functional programming is to use the idea of expressions. Okay? Expressions generally can be written on one line, and one way to turn if statements into expressions is to use the ternary, what's called the ternary operator, and that's the question mark question mark colon syntax. And I'll go in and refactor this quickly to get us to use that. So anywhere there's so this syntax can be a bit confusing if you use it relatively arbitrarily, which most people do. If you use it in a structured and consistent way, it can look relatively clear. So we'll put a return statement. And so the pattern that, if you do use ternaries, one pattern that you can do to make them look very clear is to have your if and then statements and the else on one line, and then an else statement with the colon and whatever the option is after that. So it's if this is true, then do this, else do this rest of the body. If this is true, then do fizz, else do the rest. And so this is an easy and fast structured way of getting some of this cleaned up. The other thing too is we have this body, but because this is now one full expression from here to here, we can actually get rid of a lot of this unnecessary noise by removing the return and the body bracket. So now what this is saying is take an I and with our fat arrow pointer and point to this expression. Evaluate the expression and return the value. So let's go ahead and run this. and make sure that it's returning the same thing that we saw before. So if fizz, FizzBuzz, etc., 15 is FizzBuzz. Okay. So let's go and take a look at this from a higher level. Let's clean up some of this noise. And okay, so let's go through this real quick. So what we're doing is using the enumerable range, the range operator. You can see in the help documentation, takes a start an account and returns an IEnumerable of int, meaning an iterator over a list of integers that go from 1 to 20. The next, the select statement, is going to take a function that takes an integer and returns a string. And that function will also return an enumerable string. So once we go and evaluate both the range and the select, we're going to have an IEnumerable of string, because this function returns a string. We're going to then evaluate this function and actually resolve. So we're actually going to call the 1 through 20, run that through, and get a list out. We'll then take that list and send it to the for each, which means that in this case this is an action. Actions take in one or more parameters, but have no return type. So they return in a void, or in functional programming we call that unit. So void, it will not actually return anything. And this is the perfect case where we're going to take whatever our program, each item of our program, pass it in this case is an S or the string, and do something right to modify the world, as we say in functional programming, and call it quits. Okay, so this is an overview. Select is definitely takes some time to get used to. One of the other things that we do in programming is add additional requirement. So let's add some additional requirements. So one of the things that we may want to do is we have the case of processing at 3 and 5. Let's also add an additional case where we want to output BAS in the case where 7 is the number is divisible by 7. And in this case, it's really relatively straightforward. We just add one parameter or one item to the statement. Because our ternary statement is structured well and formatted well, it's very straightforward and simple to do. So let's go ahead and run that, and we should expect our 7s to now turn to BAS, and we do 7 and 14. Another thing that we often run into is to make our programs testable. A manager comes to us and says, I would like to have this testable. Why would we want to do that, you say? In this case, let's go ahead and figure out how to make this program testable. So we have some input. We have basically a fixed range from 1 to 20. But we actually go and write out values, and so this main function is actually really would be quite difficult to test, because we'd have to somehow capture the output of the console and test that explicitly. So we don't always need to test everything, and oftentimes the logic is one of the most critical pieces to test. So and in this program, it's not really doing that much. So let's make sure that but we do want to make sure that we can test this core piece of logic. And so one of the ways that the easiest way that we can do that, because this is relatively standalone, is just to go and extract this into its own function. So it'll output a string. So a string. We'll name it, let's just call it FB for the time being. It'll take an int, because that I is an int. And we'll call that I. And we can, we'll put a body for the time being, just so it's comfortable. We'll copy this over, cut that. Okay. And then we'll just replace this FB passing in I. And we'll clean up some of our formatting here. And it's also, because we're in main, this says static, so let's add static here. And now it's happy. Clean up our formatting. Okay. So now our program, at least our main function, looks even simpler. We're going to create a range, iterate, use select, just like a for each loop, but we'll pass in what is going to be done on that for each loop. In this case, we're going to call the FB function. One of the things we can do in here as well, just to make this a little bit more syntactically clear, is get rid of our body operator as well. And now we have about, let's see here, a total of 10, 12 lines of code that is now testable. At least the core logic is testable, and is actually just one expression that is composed of pieces. So these are a couple, the select operator definitely takes some time to get used to, but this is the one thing that once you understand is really critical and very important. Think of this as not something you're not going to do, you're not going to write to a database inside of here. Do not do that, please. God forsake it. Don't do that. Think of this as a transformation operator. I'm going to go from one type of value to another type of value. So I'm going to take maybe POCO value and turn it into something else, or evaluate some type of data. And then, and the key point to notice is that our logic, our FB logic, is now separated from our actually writing to the outside world. And that's another really critical piece to this puzzle. So hopefully you enjoyed this or got some value out of this. Let me know if there's anything else that could be valuable.